What's up, folks? So today I want to talk about diffusion and osmosis, and I think these are concepts that can be sort of confused sometimes. Understandably, you know, they sort of can be a little bit misleading, maybe when taught sometimes. So first of all, I want to talk about diffusion, and I'm sure a lot of us maybe wear like perfume. Sorry about the background noise. I'm outside, but I'm sure a lot of us maybe wear like perfume or cologne or anything, and you'll get a compliment, maybe, oh, you smell nice, or if you're not smelling so nice, maybe that you'll get told that too. But basically, this happens as a result of diffusion, right? So I'm gonna draw my little perfume bottle. I'm not gonna tell y'all what type of cologne I use because that's a secret. But let's say I spray this cologne, right, and it does something like this. So we have these cologne particles, right? And maybe like 10 minutes later, we'll find that they've moved across the room, and that's how people are able to smell it. And they're spread far apart. They're not where you spray them. You're gonna spray it on your body first over here, right? This might be your body area or something. And then they move as a result of diffusion. So they're moving from a place of high concentration to a low concentration. So they're moving like, you know, down the gradient, right? You have a high concentration here and a low concentration here. That's diffusion. So now, let's say I have maybe a container with, let's say, water inside of it, and let's say I'm pouring like salt. And sometimes I boil corn, and like I put salt in my pot, right? So the salt enters the water, and maybe it's like this at first, and then maybe a few minutes later, let's say I even just left it there. I didn't even bother to boil it or something. Forgetful me. I forgot to turn on the stove or something, and I forgot to put my corn inside. Now I'm gonna find maybe like later on, if it has diffused, the particles are gonna be spread far apart. So what has happened here? Now I have my solvent, which is water, and my solute, which is my solute. Yeah. And they move from a place of high concentration to low concentration. So that's diffusion. If we're talking about like solvent solute situation, and I guess even here you could sort of say that, right? I'm not sure if this is correct, but I guess I could say that these particles are my solute, and the air maybe is my solvent here, right? Basically, just your solvent is the thing that's dissolving the other thing, right? So this is my solvent, the salt. So they move from a place of high concentration to low concentration. That's diffusion. Now let's talk about osmosis. Now osmosis most times happens with water, but it doesn't always have to be water. Now let's say I have a container, right? And if I have a semi-permeable membrane, which means, and I'm gonna draw it like this, and let's say I have, water, I have water and everything, and I have like particles here, right? And maybe they're not as well arranged as that, right? Like they're like, typical particles inside of water, right? And let's say this membrane only allows water across. It doesn't allow other things across. It doesn't allow these particles across, right? And oops, it doesn't allow these particles across. So it's only going to allow the water across. And you're going to find that something spontaneously happens, right? You're going to find that. So I want to point something out. This has a higher concentration of these particles than this, right? So what's going to happen? We're going to find that, the water, since it's only the water that can move across the membrane. Remember, these particles cannot move across this membrane. Maybe they're too big or something. I don't know. And the water molecules are smaller than this, right? You're gonna you're gonna find that. So again, I still have my membrane that hasn't changed. You're gonna find that something weird is gonna happen with the water, right? That water is gonna adjust. And I think the key here is to understand that nature is always trying to equalize things. It wants things spaced out as evenly as possible, or it wants entropy to increase, right? So the entropy here was really low, and the way I like to think of it, maybe there's a lot of order because the particles are very well contained, but now they're not contained so much, right? And it's the same thing here. They start off pretty, in one area, and then they just go and like jump all over the place. There's more chaos here. So that's what goes on here. And it's sort of the same thing that's going to happen here. We're going to find that the water is going to go to the area that has more, it wants things to be as even as possible. So nature is trying to equalize everything here. That's the way I think about it. So now you're going to have particles that do this. And well, I should say you're going to have the water that does that. So now the water has sort of managed to allow these particles to space out a little bit, and these ones maybe are a little bit more congested, right? And if I'm correct, these particles are going to have about, I want to say that they're going to be spaced apart about the same. Well, let me not say that, but they're as far apart as possible here, and they're going to be about as far apart here as well. Nature is trying to equalize the two of them, and maybe my diagram doesn't accurately depict that, right? So maybe it's going to be something like this, right? It's not going to be, they're going to be a little bit more spaced apart, right? But the point is, nature is trying to make it as as equal as possible between both sides, and that's the same thing sort of here, but it's just a different situation. So now our solvent moves from a place of low concentration to high concentration, right? The solvent does that because these particles, the solute, cannot move itself, so that is osmosis and diffusion, and that's how that works. So I hope this video was beneficial. um, Please go ahead and like and subscribe if you like this video. If there was anything that maybe was a little bit unclear, go ahead and shoot me a comment in the comment section. I might be able to explain it a little bit better. But thanks for watching, and I'll see you next time. Bye bye.